This is a period 3 oxides problem. So period 3 on the periodic table. It's going from sodium through chlorine. We're ignoring the noble gases because those aren't going to form oxides in the first place. So if we are looking at the different possible solutions here, we've got sodium oxide, we're adding it to water, and we're trying to predict what would happen. So that's with each of these. And these are one of the ones that we said memorize these, memorize these, memorize these, because it's one of those periodic trends that something particular happens when we put these oxides in water. We know that on this side of the periodic table, these oxides, when placed in water, are going to form a base, and they're going to form a hydroxide base. So in this case, we'd form sodium hydroxide, and in this case, we'd form a base as well, which is magnesium hydroxide. And then we get to the aluminum and silicon, and those are kind of a little bit either way depending on what situation. We could technically define them as either an acid or a base, so amphoteric in other words. And then we've got phosphorus, sulfur, and chlorine. Those all are going to, when their oxides are placed in water, form acids. So we go base through amphiprotic or amphoteric all the way to acid. And so we're thinking not sodium hydroxide and magnesium hydroxide anymore. We're thinking of things like acid H2SO4 or H3 or H2CO3, those types of acids. So let's look here. We're adding these oxides to water. We want to produce the highest pH, which means the most basic. Okay, I want to find the most basic of them all. And so that requires, again, a little bit of remembering. Sodium hydroxide is one of our strong bases that we said to make sure we memorize, like potassium hydroxide. Sodium hydroxide is another strong base, and so that means it's going to have the highest of the pHs, which again, pH scale, it's going from like 1 to 7 being neutral, all the way to 14 being very, very strong base, 1 being very, very strong acid, 7 being again neutral. So we're looking for something closest to 14. A would be the correct answer.